Chapter 1, Section 3. I'm going to break this section into 3 videos, I think. And I'll try to name these a little more effectively so you could pick this up or find the video again if you want when you're working on something. So I'll try to put some indications of just the piece that's in the video. So like this one, we're going to talk about the factors and prime factorization and fraction notation. They're going to start with 2 right here. And fraction notation comes, basically it's really a division. It's a comparison of 2 numbers come in fraction mode. There's a lot of different ways to do that. And then we're going to talk about the multiplication, addition, subtraction, and division of those kinds of fractions. But first we need to understand what a fraction is. And again, I know that you've probably know what a fraction is, but really focus in on the language. We want to get the language down if you go on to other math courses or those kind of things. It's very exact languages in algebra. So fraction notation is a numerator, which is the top part, and denominator, which is the bottom part. Separated, by this fraction bar, sometimes called a division bar. Those kinds of things, because it does indicate a division. And we'll talk about all these. And this is where a lot of the confusion comes out, is that when we get into fractions, there's so many different ways we could represent something. If you don't really kind of understand what it means, it can be very confusing to try to memorize things. And I really discourage memorizing technique or methods, basically, to do certain types of problems, because we're going to get to the point where there's going to be like 17 different ways to do the problem correctly. And if you try to memorize all those, you'd have to have a lot better memory than me. But so anyhow, they got the numerator and denominator defined. And then we're going to talk about factors. Factors are parts of a multiplication, and prime factorization, they actually bring in a number set here too, which later on we're going to represent better ways. So we're going to bring in some methods to represent infinity, because this natural numbers they're talking about is 1, 2, 3, 4, 5, and these dots means that continues in that pattern forever. In other words, there's an infinity of natural numbers. Counting numbers sometimes it's called, but in this book it'll be natural numbers. And that's what they tell us those dots represent. Well, factorizations are basically, can I take this number like 12 and write it as a multiplication of something? Because that would take factors to do that. So here are several factorizations of 12. Well, every number has 1 as a factor. 1 is this magical number in multiplication. It's called the identity. When they start labeling, putting a special name to a number, it's because we're going to use that, and hopefully you'll understand this identity property really well in the next few sections, really. So we could write 12 as 1 times 12. Yeah, that the product is 12. The factors are 1 and 12, right? Product means answer to a multiplication. I could also write it as 2 times 6. So 2 and 6 are factors. I could write it as 3 times 4. And also I could write it as 2 times 2 times 3. This is going to be important here, because that each one of these numbers is something called prime, and we'll talk about that in a little bit. Now, it is easy to overlook a factor of a number if factorization is not written out methodically and those kinds of things. So they say, well, list all factors of 18, and you'll get some questions like this. And really, this is about mostly about, because we're going to use is to understand what factors are. So if they want all the factors of 18, well, I know 1 and 18 are there. 2 goes into 18 9 times, right? 2 times 9 is 18, and 3 times 6 is 18. Notice how they're going through here. They start out with 1, yeah, that works. 2, 3, And something I should talk about too a little bit. There's some divisibility rules that are handy. That's a good one. I'm not going to talk about it much, but look up divisibility rules on Google or someplace, and they'll list some of these things. Some of them are real handy, like even numbers are always divisible by 2. There's kind of interesting things around 3 and 9. 5 is pretty easy. There's ones places is 0 or 5. Tens are easy, right? The ones place is 0, so on. Here, and then I said I wasn't going to talk about it, but I did. Okay. Look up that 3 and 9 is kind of interesting. So they go through the numbers right up to 6, and they say, hey, we already hit something that had 6 in it with 3, so we must have covered all the factors. Okay. So then if we listed them, that's how we'd list them. It's 1, 2, 3, 6, 9, and 18. They usually list things in a descending order. Well, here's the definition of prime. Now, prime is a number that only has 2 factors. In fact, it actually has exactly 2 factors. That's the definition of prime. And it's said a lot of different ways, but it has 2 factors. If you remember that, it has exactly two factors, then it's prime. That'll take care of the definition of prime. Here they tell us a prime number is a natural number, that counting number, that has exactly 2 different factors. Now they say different in here, and they say that it's the number in itself and 1. Here are some examples of them. And then I'd ask a question, based on that definition, is 1 prime? Well, how many factors of 1 are there? Well, I can go 1 times 1. Well, 1's the only factor then, so it has exactly 1 factor. So by definition of prime, 1 is not a prime number. Okay? It's a unique number called the identity for multiplication, really. So now, if it's not a prime number, then it's called composite. In other words, any number that has more than 2 factors is composite. So they're going to ask us questions on testing that. How would I test that? Well, I want to start looking for factors and do that. Okay? And I could list it the same way, like with 29. I go, well, 1 times 29. It's not even. 2 doesn't go into it. 3 doesn't go into it. 4 doesn't go into it. 5 doesn't. I could go all the way through there and find out that there's no other factors of 29. So it has exactly 2 factors, 29 and 1. So this number is prime. Once I find a third factor, I know that it's not prime, and that's what they're asking us, is to say whether it's prime, composite, or neither. Well, and here comes that 1 thing. 1 is not prime. It does not have 2 different factors, and so on. So they kind of covered all the bases with that example. Now, this is probably overlooked a lot, but this is really important. Every composite number can be factored in a product. Product meaning answer to a multiplication of prime numbers. Such a factorization is called the prime factorization. So in other words, say that again. If I prime factor, if I say what prime numbers can I multiply together to get this original number here that I'm talking about, like 36 in this case. Now, I have another video that I stored that talks about doing factoring trees and to get prime factorization. That'd be a good time to look at that. It's a method to tree out your factors and stuff, and I would look at that video. There's a lot of other resources that show that. You can look up factor tree, and you'll see all kinds of YouTubes and a lot of other resources talking about how to do that. But what our goal is when they say prime factorization, I want to make sure that the multiplication of numbers that equal this product 36, that all of these are prime. In other words, there's exactly 2 factors. Notice 1 is not in there because that's not a prime number. Well, they start breaking it down this way. They say 36 is 4 times 9, and 4 is 2 times 2, and I'm done there because 2 is prime. 9's not prime because there's 3 factors. So I break that into 3 times 3, and 3 is prime. So this 2 times 2 times 3 times 3 will equal 36. And all those factors, parts of the multiplication, are prime. And that would be a prime factorization. In the other video, I go through two things. One, simplifying fractions and LCMs, and using prime factorization for both of these to simplify and also to add fractions. And I'll talk about this. We're getting into that in the next couple sections. So those other videos are really just me working on paper, but be a good time. They're short little videos to look at that too as some additional info.